let's go ahead and get started, everyone. I'm going to start off here today with a quick overview of our company, SimpliPhi Power. So we have a whole portfolio of different products that we're offering now. SimpliPhi Power got started producing batteries back in 2010. We've been using lithium iron phosphate for this entire time. And so we have a very strong track record of developing intellectual property, refining batteries, working well to provide really safe batteries that offer you a non-toxic solution to using lithium to replace lead. So we are a cobalt-free chemistry, and we'll get into what that means. We'll talk about different types of lithium-ion batteries in this presentation. Additionally, we'll talk about how there's no risk of thermal runaway with these LFP batteries. And we'll talk about those certifications, UL certification, and then the United Nations Department of Transportation certifications that have to do with the safety of transporting these batteries internationally. So the products that we have are proven. As I said, we've been doing this for over a decade, over 12 years now. We've deployed our batteries in, I think it's over 50 countries now. We have well over 150 megawatt hours installed worldwide in many different countries. We've worked with the US Army, done safety testing with them, as well with the Marine Corps. And so we have a history of testing our batteries for safety, which should be an important consideration when you are doing installations or you are selling batteries to customers. Knowing that that battery is safe for them to take home, store inside their house, utilize, etc., is very important to us as well as our customers. We've released a new product, the SimpliPhi ESS, which is an inverter combined with online monitoring software, the Energy Track app, as you can see in the picture there. I'll highlight it with my mouse. And that includes outdoor rated batteries. So we have an outdoor rated inverter, outdoor rated batteries, and remote monitoring with the Energy Track app. If you're interested in larger systems, we also offer high voltage solutions. And so for very large projects, we have high voltage solutions, and we have a whole engineering team that can help you on the design and optimization for your particular needs. One of our goals with SimpliPhi is to really make battery storage a simple, easy option. And so our systems are designed, some of our batteries, our PHYs, are designed as lead acid replacements, an easy way to upgrade customers that might have an older system, but want to add batteries to it and get rid of lead acid batteries, which are no longer functioning well. Our systems store energy for critical backup. There are lots of reasons to want to have electric backup at your home. This maximizes energy security, especially if you have a business where it's critical to keep the lights on, etc. And so we can get into different reasons, such as time of use and peak shaving and demand management, if you have questions about those at the end. So as I mentioned, we are releasing this new energy storage product, and this is together with Briggs & Stratton. So SimpliPhi was acquired by Briggs & Stratton a year ago, and we're now able to really leverage the knowledge base of both of our teams. And we are showcasing that with this new product that we're releasing, which is this outdoor rated ESS. It's a vertically integrated place. It offers you the ability to use our proven, batteries that have been around for a long time, together with our new inverter and our Energy Track app. And so you have one company to deal with instead of multiple different companies. One line for tech support, one line for sales, one line for engineers, etc. So we're excited to be releasing that. And if you're interested in that, we can talk about that at the end. And we have more trainings around about how to install these kind of systems. As I said, we have a global footprint. We've installed in many countries around the world, 40 and growing, probably more than that now. This graphic might be a little bit dated, but we've got over 150 megawatt hours installed around the world, and we've been doing this since 2010. So we've got a long history of being able to provide support for lithium iron phosphate batteries. So there are a lot of reasons our customers want these batteries, right? And the challenge that we're facing now is that energy costs are rising, and everybody has experienced that just in terms of filling up their cars at the pump in the recent years. European electricity prices have been expected to rise at 30% by 2025, and this is even before the war in Ukraine, right, which has really exacerbated the problem in Europe. And so the cost of energy is rapidly rising in Europe, which is causing a huge demand for solar systems, etc. Again, there are many people around the world that rely on generators for backup power, and as the cost of diesel has been rising, the amount that these people pay per kilowatt hour is $1 to $3 in some circumstances when you have a generator that's not very efficient. So there are many reasons that people in those circumstances would want to use battery backup as a much cheaper way to have access to electricity. We have failing infrastructure. Those of us who live in California, Daniel and myself, are very aware of the fires that have been caused by utilities. So utilities and transmission lines can lead to fires. And that has resulted in electricity companies in California having to shut the power off to different customers based on environmental conditions, etc. And so, Roberto, I don't unfortunately have the ability to unmute you, but if you want to ask a question in the Q&A, we can try to get to that question, and Daniel might be able to respond as I speak. So since 2003, the number of weather-related power outages it's doubled, and it's growing, and this is causing a lot of financial loss to businesses and people that need to keep the lights on. And so this failing infrastructure is a reason why people are turning to solar and battery backup. And of course, the other elephant in the room here is a desire to decarbonize, right? Global warming is a real threat, and people are wanting to move towards sustainable 100% clean energy goals, and you simply can't do that without having battery storage, without having some way of storing the energy. So wind farms, solar plants are a great way to harvest energy in an environmentally friendly way, but again, they're intermittent, and so we need storage. And as the population grows, we've got economic growth, and we've got electrification, and many of us are aware that we have a large number of people driving electric automobiles now. And to advance my slide here. So let's get into battery chemistry, and I'm happy to talk with you a bit about this. There are a lot of different kinds of lithium-ion batteries, and so when people hear lithium-ion batteries, sometimes they might think that all lithium-ion batteries are the same, and they're not. And the major difference in the chemistry here has to do with the positive side of the battery, which we call the cathode, and that is typically made up of a metal oxide, but we are using something a little bit different that's based on lithium iron phosphate. And notice that on the left side of the screen here, as I lay out some of the different battery chemistries that are commonly utilized, such as lithium cobalt oxide, which is quite common in vehicles due to its high energy density, low weight, nickel manganese cobalt oxide. The lithium manganese oxide batteries are typically used in power tools, etc. Lithium iron phosphate is really, it's not a brand new chemistry, but it's been really growing in popularity. And then nickel cobalt oxide. So the common theme there on the left, with the exception of the lithium manganese oxide, which also can have some dopant level of cobalt in it, is having cobalt in the cathode. And that cobalt is a toxic element. It's a rare earth element. The mining practices around that are not environmentally just or not socially just in many ways. And we'll talk about that just briefly today. But notice that lithium iron phosphate, so first off, lithium is common to all of these batteries. It's a fairly common element. We can harvest it through, it comes dissolved as a salt. And I'll talk about ways that that's produced. But the cobalt, it includes, mining practices that are questionable. The other nice thing about lithium iron phosphate is that, you know, not having rare earth metals in there, having an iron used as the cathode, means that you have a more environmentally friendly chemistry, and it's stable and it's not toxic. Phosphate is present in our DNA. It's a very common anion. And so there's nothing toxic about lithium iron phosphate, but we do have to be careful, and we'll talk about disposal a little bit. We do have to be careful because lithium is something that we don't want in our water supply. So I'll talk about that a little bit later, but the cobalt makes the batteries a bit more dangerous. There are reasons why people choose to use them anyway, and that has to do with energy density. However, I will say that over half of Tesla's cars now in 2022 have been produced using lithium iron phosphate. Again, we're one of the main, we're one of the original companies using LFP to produce batteries in the US here in Oxnard, California. So let's talk just a little bit about form factor. Form factor is used here as a way to explain how the battery is constructed. So we've all seen these pouch cells and different pieces of electronics, whether it's a headphone or an older phone. Pouch cells are the most economical way to make a battery. And the pouch cell is really exactly what it sounds like. It's a pouch that has cathode and anode kind of folded up inside it, but it's also the most risky type of battery cell. And so nobody uses pouch cells to produce big batteries for home backup. Pouch cells are easily punctured. I'll have a picture on the next screen of a pouch cell that is kind of ballooned, and that is a problem with pouch cells. The two cells that are most commonly used in home backup are prismatic cells and cylindrical cells. Cylindrical cells, you can think of a AA battery, a cell that's based inside a steel cylinder, and that steel cylinder provides structure and safety to that battery. We're all very familiar with them. That's what a AA, AAA battery looks like. Prismatic cells are a little bit different. They are inside of a case, and that case allows them to put a large amount of energy, kind of a high energy density into the case. The case is rigid, unlike pouch cells, but there are problems with prismatic cells, and one of those has to do with the migration of heat inside the cell. So prismatic cells, because it's a large volume, typically have a little bit more problem with heat generation inside the cell, and they're less safe due to the nature of that heat buildup and the potential for problems related to fire. All lithium-ion batteries can catch fire, and I'll talk about that, but LFP is the safest. So let me get into that. So again, at SimpliPhi Power, we've known for a long time that lithium iron phosphate is the best battery chemistry to use. We've been using this all along. We've been refining our batteries for 12 years now and produce a really safe lithium iron phosphate battery that can be used inside homes. As I said, we use cylindrical form factor, and there are many reasons for that. One is it's good at dissipating heat. Two, it offers the most safety in terms of if a battery is to sustain damage. So you can imagine a badly installed battery, or maybe somebody pulls their car into the garage and accidentally runs into the battery unit. Lithium iron phosphate with cylindrical cells is the safest way to have energy storage in the house, and I'll get into that. So we use cylindrical cells, and I'm going to speak to you about why batteries can catch fire and about why cylindrical cells are basically the best way to prevent that fire, and what SimpliPhi does to ensure that we don't have these events such as thermal runaway that I'll talk about. So safety is an important consideration. What you would have if you opened up a cylindrical cell is demonstrated with this figure that I'm outlining with my mouse. And that figure, what it shows you is a copper foil and an aluminum foil. And that aluminum foil is the positive side of the battery, and the copper foil is the negative side. One of them is called the anode and the other is a cathode. Those are electrochemistry terms. But basically what has happened, the way the battery is constructed is that the aluminum foil has some graphite on top of that, and the lithium can sit inside the graphite. There's a separator layer. You can think almost of something like wax paper that's permeable to lithium ions. And then there's an aluminum side, which has a metal oxide layer, or in the case of LFP, a metal phosphate layer, iron phosphate. And so the way the battery works is that lithium ions, when you charge them, are pumped up into the graphite, and those ions sit in the graphite, but they would rather be in the oxide layer, the metal oxide layer on the cathode side. The reason that I'm telling you this is that there's an electrolyte in between all of this. So the electrolyte is, think of a gel about the consistency of diesel fuel, which is absorbed into the graphite layer, into the metal oxide layer, and through the porous separator. That is the safety consideration. That is what catches fire. It's an organic solvent, and that organic solvent is what catches fire if a battery starts to burn. Okay, so the whole thing is just basically a sandwich between two metal foils, the copper foil and the aluminum foil, and that gel is embedded inside there. So that electrolyte is the thing that can cause some safety concerns, and we'll talk about that if the battery gets very hot. Okay, so let's just briefly run through the different chemistries. And I mentioned the use of the lithium cobalt oxide, typically in automobiles, and the nickel manganese cobalt oxide used in power tools. And there are many other lithium chemistries, although most are moving towards lithium iron phosphate, even cars, right? Even cars are going towards lithium iron phosphate. So the reason for this is the safety around lithium iron phosphate. So you get a little less energy density, meaning the same size battery can give you, the same size battery and the same weight battery can give you a little less energy with the lithium iron phosphate. But in terms of battery backup, that's really not a major consideration, right? If your battery is 20% heavier inside the house and it's just sitting in a rack, that doesn't bother you. The reason the other cobalt-based chemistries exist are because you're trying to make vehicles very light. And so typically to have light batteries with high energy densities, they're using cobalt. One of the problems with cobalt, and so I'll run through the chart here, is the danger of thermal runaway. I'll get into what that means, but basically it's a chain reaction where one cell can get hot, catch fire, and catch other cells on fire. Lithium iron phosphate has the least likelihood of going into thermal runaway. You really have to push lithium iron phosphate in order to get it to catch fire. All the other batteries, you can see all these other chemistries, and there are some more that I don't have on here. There's a lithium titanate battery, which has a slightly different anode than graphite. But for all of these batteries include cobalt, and cobalt is really the thing, the cobalt oxide is the thing that makes that thermal runaway more of a problem, and what's given lithium ion batteries a bad name. Do these batteries have toxic elements? So the toxic element here is that transition metal, the cobalt, and like I said, lithium iron phosphate is something that your customers can feel good about, right? It's not toxic. It's not a metal that will get into water supply and cause problems if disposed of improperly. Now notice that I've said here, none of these are landfill safe. So I want to point that out, and that the reason for that, I think you probably know, is the lithium, right? So lithium is something that does need to be recycled, and there are recycling companies to recycle lithium iron phosphate batteries. Much easier to do because they don't contain cobalt. Again, I mentioned earlier, there's abusive mining practices that are kind of surround the cobalt-based chemistry that we have to take into consideration when we're thinking about the social equity and the design of the battery itself. Some customers might not care about that, but others do. And the nice thing to know is with SimpliPhi batteries, our lithium iron phosphate is a battery that takes into consideration those things. And SimpliPhi very much does care about social equity and social justice. Is ventilation required? Well, some of these chemistries can heat up the electrolyte and give off gas in the similar way that you might know that lead acid batteries could give off hydrogen gas. The gas in this case is the electrolyte boiling. This does not happen with lithium iron phosphate batteries, but ventilation is required for other chemistries. I want to point out here that in cases where you would have large skyscrapers, etc., these are important considerations. And together with Tesla Powerwall, SimpliPhi batteries are the only approved batteries, the only other company with approved batteries to go into skyscrapers in New York City. Ventilation requirements mean that other battery chemistries would have to be ventilated and in some cases cooled. And so that's the next thing on here, whether or not you need cooling equipment in order to run these batteries. In certain circumstances, AHJs may require safety monitoring equipment. I know New York City does require safety monitoring in terms of off-gassing, etc. And are these chemistries able to withstand high temperatures? And so the answer here is that LFP is got the highest temperature range. The battery can be the hottest and still operating. Okay, so what is thermal runaway? So again, we're getting into safety, and there are different reasons why lithium has been given a bad name. One good example of that, right? And you may remember 10 years ago or so, then the Samsung Galaxy Note 7 was banned on flights. Maybe that was as much as 5 years, just 5 or 6 years ago. I was using a Note 9 until recently, but why was it banned on flights? And what is thermal runaway? So in the event of damage inside a battery, whether it's due to dropping the battery or whether it's due to an accidental puncture of the battery, or even if it's just due to abuse, the battery is overcharged or overly discharged or charged too fast. What can happen with a lithium ion battery is it can get too hot. And again, this battery is an example of a pouch cell inside the Note 7, which has burned. But I'm going to get into thermal runaway with lithium-ion batteries. And what happens is, so imagine that you short circuit a battery, or imagine that you accidentally puncture a battery. Think of a car crash puncturing a battery. What happens is that now the cathode and anode inside the battery are in direct contact with each other. And so they're producing heat inside the battery. And so you can imagine that cell that is punctured, or that cell that is damaged due to abuse or some type of circuit failure inside the battery, where the cathode and anode are in direct contact, or that's producing heat inside the cell. And what happens is the cell temperature starts to rise. So if you remember a few slides ago, I was talking to you about what is inside the battery. And I told you that there's an electrolyte inside there. And that electrolyte is an organic electrolyte, meaning something like gasoline, petroleum type product. It's actually a salt. It's a solvent that has chlorine and it has carbon inside it, and it can burn. And so this solvent can get hot, and if it gets too hot, it will off gas. And so all lithium ion cells have a pressure valve in the top of those. And if that pressure valve, if the battery gets too hot, too much pressure builds up inside the battery, the solvent, just like water can boil, the solvent can boil and turn into a vapor. And so that pressure is released out the top of the battery cell. Thermal runaway is when one battery starts going into a cycle like that. Again, this is very rare, but it can happen, especially in cases where you have extreme damage to batteries, like a car crash. So imagine that the center cell gets really hot and starts off-gassing. That's a flammable gas that's coming off. And if you have an ignition source, like a spark, right? Or even if the cell just gets too hot, it can start burning. If one cell does that, it starts to heat the other cells up around it. The other cells around it can then start off-gassing, and you have a runaway fire. And that's the challenge with lithium-ion batteries. Again, LFP batteries are the most likely to not experience this runaway. They're the safest chemistry. Okay, so here's some data about thermal runaways, and this data is talking to you about lithium iron phosphate, about the temperature at which it does go into thermal runaway. So these units are in Celsius. If you take a lithium iron phosphate battery and you heat it up to 100 degrees Celsius, which is the boiling point of water, nothing is going to happen. You will have to heat a lithium iron phosphate battery all the way up to around 200 degrees Celsius, which is probably around 400 degrees Fahrenheit. You have to get it very hot, like putting it inside an oven, before you can even get it to get hot enough to go into thermal runaway. On the other side of things, a nickel manganese cobalt battery will do this at a lower temperature. So it's about 50 degrees Fahrenheit lower, 170 degrees Celsius. You can get a nickel metal cobalt oxide battery to do this. Then the next thing to consider is how much heat is released. And I have a graph on the next page, but how much heat is released when the battery goes into a thermal runaway, because that's another consideration. The more rapidly heat is released, the worse fire that you will have. Again, lithium iron phosphate, the safer battery here, it doesn't get as hot. Even if we push it by putting it inside an oven to catch fire, that fire will burn at a much lower temperature, around 400 degrees Celsius, compared to 675 for nickel manganese cobalt oxide batteries. So again, this is just highlighting the safety of LFP batteries. And when you're putting batteries inside a house or an apartment building, this should be an important consideration. Really, LFP is the only battery that should be used in home battery backup. So this graph is a little bit hard to understand. What you have on the vertical axis here is normalized heating rate. And what does that mean? It basically means the amount of heat that is released due to the battery. And the word normalized here means that we're dividing by the size of the battery, right? So the heat released is we're looking at the degrees Celsius, is the temperature of the battery changes, right, per minute. So how quickly does the cell heat up? And then we also want to divide by the amp hour. So if you have a bigger battery, you're taking into consideration what the size of the battery is in amp hours. When you look at this, LFP is in the dark blue, and it's right along the horizontal axis here, meaning you can barely even see the heat given off by LFP if you compare it to the other cobalt-based chemistries. If you zoom in on this, there is a peak for the LFP batteries, but it's 100 times smaller, right? It's much, much smaller. You can see that the lithium cobalt oxide batteries are hitting the scale of 450 for normalized heat released, whereas you're only at 1.5 for lithium iron phosphate. So again, just highlighting the safety for you there. That doesn't mean that it's perfectly safe, right? You can still have off-gassing events, like in case of having some type of fire in a household, the batteries, LFP batteries can go into runaway, but you have to get them really hot before they do that. And if they do, they release a lot less heat, so it's a lot less dangerous. Okay, so lithium batteries, which contain cobalt, often require a fancy cooling equipment, right? And I say fancy, they're typically circulating a cooling fluid. This is an example of somebody's personally built battery, right? And what he's designed here is a battery which has got cobalt-based cells inside it. And because of that, he's got a cooling system that he's designed. Now, I don't want to pick on this. I think it's an awesome project. But keep in mind that if you do have cooling equipment running for your batteries, there's a cost to that, an energy cost too. Right, so you're going to have a parasitic draw from the cooling equipment, reducing the efficiency of your battery, et cetera, and also increasing the cost of producing the battery. Right, because lithium iron phosphate batteries are safer, run at lower temperatures, and have less likelihood of thermal runaway, this stuff is not needed with SimpliPhi batteries. Okay, can lead acid batteries go into thermal runaway? Well, lead acid batteries are a bit different from lithium ion batteries. We don't need to spend a lot of time on this because most people are not using lead acid batteries anymore, but there are problems with deep cycle lead acid batteries, right? And one of those is that these batteries can get hot. And so if you do charge a if you do charge a lead acid battery too quickly, it's an exothermic reaction, right? Or sorry, it's not an exothermic reaction, but what will happen inside a lead acid battery is that as you increase the temperature, the battery will accept energy more rapidly, right? And because it's accepting energy more rapidly, the battery can get hotter and hotter. What happens inside a lead acid battery is you have an aqueous solution, which means a water-based solution. So you have a sulfuric acid inside lead acid batteries. If you get them too hot, now this says 125 Celsius on here, but really that the sulfuric acid will start boiling at a lower temperature than that. And so lead acid batteries have to have venting on them. And so as you know, you can have electrolysis happen inside lead acid batteries. You get water too hot, it turns into a vapor. You get that vapor too hot and it can create pressure inside the battery. Additionally, you can have hydrogen produced, and so lead acid batteries can explode. There's an example to the right where there was not an explosion, but there was an overheating and these batteries melted. Great, let's talk briefly. So if you have more questions about lead acid batteries, I'm not sure I know the answer, but I'm happy to try to answer some questions in the question and answer session at the end if you have them. So briefly want to talk about mining of lithium. So a lot of people think that lithium batteries are very bad for the environment, that mining is a destructive process. Lithium is typically mined from salt. Now, I know that in Australia, they have some methods of mining that involve using ore. I don't actually know much about that, but the majority of the way that lithium is mined is by dissolving salt that's underground. So if you look at water that is underground, that is kind of embedded in salt layers, if you pump that water out, that water contains lithium, which is also a salt. It dissolves in the water. And so that salt, just like we harvest sea salt from the ocean, you put that salt into ponds, and as the water evaporates, you're left with the ions, which were part of the solution in the water, and lithium is one of those things. So it's fairly easy to mine. And it's unlike cobalt, where you do have, it's a transition metal, it's a rare earth metal, and typically it's mined in the DRC as well as other places where mining practices can be questionable. So let's talk just a bit about that. Again, if we're using cobalt, there are ways to mine cobalt safely, right? However, in DRC, there are abusive mining practices that do happen. It's not the majority, but it happens. My wife is from Ghana in West Africa, and I can tell you one of the biggest problems with mining in West Africa is one, the kind of the abusive practices that take advantage of poor people, but two, the negative impact on the water supply. So a number of the rivers in Ghana are polluted and choked of oxygen due to just the brown silt from mining being present there. So if you have questions about that, we can talk about it. Again, SimpliPhi uses iron phosphate, which it does not involve the mining of rare earth elements. And so if you have customers that are concerned about this thing, you can tell them these SimpliPhi batteries, don't have this problem with mining and rare earth elements that are toxic. Okay, so let's talk a little bit about battery safety standards. So safety standards really exist to protect the installers, to protect the homeowners, to protect the customers. Some of these safety standards have to do with FAA and air shipping. And so since 1991, this statistic is 2 years old now, but I'm using the same one. Since 1991, 206 separate incidents occurred involving the combustion of lithium batteries on airlines. So I have been in a situation where I'm doing a project in Africa or in Thailand, and I've got my power tools, I got my DeWalt tools, and I want to get on board the flight, and I'm having trouble getting my batteries approved, even though they meet the regulations. And the reason for this is really this safety consideration with an example of that phone there again, but again, 206 separate incidents involving a fire inside an airline, right? So why is this a case? Well, one of the things is that especially inside your checked baggage, right? Your battery goes from a really warm room temperature to, once you get into the upper atmosphere, now you have a very low pressure and a really cold temperature. And then as you come back down to the ground, the temperature is elevating again because you're getting back to, normal conditions. And so if you have a battery which is kind of going through pressure cycles as well as temperature cycles, it can be rough on the battery. And that's why most of the airlines recommend that if you do take power tool batteries, they're in your checked luggage, or sorry, they're in your carry-on luggage, right? So FAA has some regulations. There's the UN .38.3 around transporting batteries, and this is to ensure that batteries are safe on airlines. Most lithium-ion batteries, especially large batteries, are not safe on airlines. However, SimpliPhi has approval to take our batteries on board airlines due to our certification with having LFP chemistry. So our batteries are approved for sending on airlines. There's a UN 3480, which regulates how batteries have to be packaged if they are shipped or if they are transported on airlines. And so I just want to highlight here, keep your original packaging. So if you buy batteries, especially if you're transporting them internationally or on flights, keep your original packaging because they have to be packaged in certain ways. And if you're packaging this on your own, it's harder to meet those regulations. So keep at least a couple of your boxes if you're transporting them like this. And so what goes into these tests? So I'm not going to spend a lot of time talking about it. I gave you a rough idea of what happens. So again, when you get on an airline, especially your checked baggage, it ends up in a non-pressurized environment in the cargo hold of the plane. And so altitudes have low pressure, low temperature. And so there's a test, part of the UN 38.3 is to simulate that cycling of pressure. And then thermal, there's also a cycling of the temperature, right? You're going from 72 Celsius, a very hot temperature that you typically wouldn't experience, right? But a hot temperature down to a really low temperature. And we're doing these rapid cyclings in these tests. Again, SimpliPhi has passed these tests. There's also vibration, right? If you're transporting a battery and you're on a runway, right, that battery is vibrating and banging. And so the circuits inside that battery have to be tested for vibration to make sure that something doesn't come loose that's going to cause a problem when that airline is up in the air, when that jet is in the air, right? And then again, shock tests where you could drop the battery, maybe it tips over in the cargo hold. And so all of these things go into reasons why these safety regulations exist. We want to make sure that the airline is safe. We want to make sure that other passengers are safe. And we want to make sure that the battery is not going to cause a major issue for a flight. Then there's an external short circuit test. So in this case, right, we heat the battery up. It's heated for 6 hours. I don't know a lot about this test, but it's heated up. And then we short circuit the battery and make sure the battery is not going to go into thermal runaway. This would not work for cobalt-based chemistries, right? You short circuit one of those batteries, more likely than not, they're going to go into thermal runaway and they're going to catch fire. So this is done, short circuit LFP battery. It still stays below 170 degrees Celsius and does not catch fire. Again, SimpliPhi's batteries have passed this 38.3 test. Overcharge. We charge the battery 1.2 times what it should be. We go above the max charge voltage. And again, you must not catch fire. And so this is what goes into this test. And this is why only certain batteries are approved for transport. So if you are transporting batteries, before you take them to the airline, make sure that they're approved like our SimpliPhi batteries are. If you have any questions about that, feel free to contact us before transporting. We'll let you know which batteries are safe, etc. All right, so some standards around testing. So you probably are all aware that electronics in the US, especially batteries, go through rigorous safety standards, and these safety standards are carried out by Underwriters Laboratory, which is a third party which tests equipment in the United States. Most of the certifications are around whether or not these batteries and battery backup will be safe, right? And so fire departments, again, these batteries are kind of burning of an internal fuel source if they do have a fire. And so fire departments such as the New York Fire Department have regulations around it. UL certifies which batteries are safe, and we've gone through these UL testings. We go through these UL testings every time we release a new product. So I'll talk a little bit about 1642, which is a cell level safety, 1973, which is a module or entire battery level safety, as well as 9540, which pertains to the entire system. We note here that 9540A is not a certification, it's just a part of the testing process, and I'll talk about that. So UL certifications are needed. So anytime you're installing these in residential facilities or commercial facilities, to meet the building codes, you have to have these safety certifications. Do not install a battery that doesn't. They're needed for insurance purposes as well. If you're going to have fire insurance on your building and you've installed batteries that don't have the UL 9540 certification, then the insurance would not cover, right? So you want to make sure that you meet all of these conditions. And of course, the building inspector is going to be inspecting for this as well. Okay, so what is 1642? This is really a cell level thing. You imagine that AA size battery, or in the case of SimpliPhi, we have 26650 lithium ion batteries, lithium iron phosphate batteries. And it's taking one of those cells and running it through a series of tests. These can include drop tests, it can include vibration tests, it can include heating cycles or crushing the battery. There are great examples online of taking nails and driving them through batteries, so a puncture test. And all of our cells are tested. They've gone through this UL 1642. Module level battery safety is at the battery level. So if you were to take one of our batteries as an example, there's a Phi battery that's there, right? The 1973, it contains many, many cells, right? So there are a lot of battery cells inside, or there's a lot of lithium ion cells inside this battery. And so this is an entire battery going through similar safety tests. Again, most of these safety tests are to make sure that the battery does not catch fire and pose safety considerations for fire departments as well as customers. And so our batteries all go through this UL 1973, and we can provide proof of that if a building inspector asks you. Then there's a final UL test. It's known as the 9540, and this is needed for installations in the US. 9540 includes a whole system level safety. So it would include if you have 4 batteries as part of an energy storage system inside a cabinet with an inverter, and the inverter requires a special safety test as well. It's a 1741 for the inverter. It ensures that the entire system has adequate safety standards built into it. Again, they do fire testing with these and ensure that they're safe. And these have to be completed for installations in the US. Okay, so one more time, the UL 9540 is a whole system level. It includes the inverter and the batteries, or the charge controller and the batteries. And so we have been certified with a number of different inverters like Schneider and Solarc, etc. The 9540A, again, it's just a test. It's not part of the certification. The 9540A is just a test to inform how to run the 9540 certification. So there's a test report is needed in certain regions when you're doing this installation. New York City is a company, or is a fire department that we've worked with. And as I said, we are the only other battery company other than Tesla Powerwall that is allowed for installations in New York City right now. New York City has an added requirement that you have off-gassing sensors for any lithium-ion batteries, and we have systems that have been approved with these requirements. So if you're doing an installation in New York, know that we meet the fire codes and that we have approval for an installation there. And if you are doing an installation in New York, we can help you with the monitoring systems, which we have packaged as part of our BOSS and our access units for systems for New York. Okay, so almost done with the safety and standards here. I want to go through briefly disposal of batteries. I have a mistake on this slide, and I'm sorry about that. No lithium batteries are safe for landfills. Batteries in general should be recycled, with the exception of AA, AAA simple alkaline batteries can go straight in the trash. Otherwise, most batteries include things like lithium, which should not go in a landfill. Improperly recycling of batteries, so disposing of them in the trash, can result in serious problems. And what's shown here is a recycling plant that had caught fire due to an improper disposal of a battery. So there are toxic metals in some types of batteries. Again, lithium iron phosphate does not include these toxic metals, but all batteries should be recycled, and there are recycling systems in place where you can recycle lithium batteries. Okay, so just a word, and I won't speak about this because we have whole trainings around how to properly install batteries, etc. But there are some safety considerations when you're installing batteries, and I would be remiss if I didn't talk about them right here. So one thing is, if you don't know what you're doing, hire a professional, right? Ask. Proper sizing of breakers and fuses is very important. Typically, breakers don't respond immediately at the amperage that they're rated for. So a 100 amp breaker might not trip until 120 amps, etc. So don't rely on breakers and fuses for your only safety. Make sure that you size your system properly. All of our batteries really have a C/2 charge and discharge rate. And what does that mean? It means the capacity divided by 2 hours. So in other words, if you were to take one of our batteries, you wouldn't want to charge it up in 1 hour. You would want to charge that battery from 0 to 100% in 2 full hours. Okay, so that's what a C/2 capacity means, right? The capacity divided by 2 means you can charge the battery up or fully discharge the battery in 2 hours, and we typically specify this in an amperage, right? So if we have a 75 amp hour battery like our Phi, and you take 75 amp hours, you divide by 2 hours, you get 37.5 amps. Okay, so that's our charge and discharge rate for that battery. We always recommend a C/2. Now these batteries can all surge, and they can surge to a rate of C, but we only do that for about 10 minutes. We limit that because as you're surging a battery and discharging it really rapidly, you're generating some heat inside the cell. And so as that temperature of that cell builds up, we then stop to prevent damage to the cell and the greatest longevity to the battery. If you follow our C/2 discharge rates, you can expect many years of success from lithium iron phosphate batteries. In fact, you could expect, if you really take good care of your batteries, 10,000 cycles out of your batteries. If you do cycle once a day, that would be 27 years, right? Lithium batteries are greatly, especially lithium iron phosphate batteries, greatly exceed the performance of lead acid batteries, which is why this industry is so exciting. We have a lot of resources on our website. I'm going to point those out to you. But first, let me just talk about personal protective equipment for use when you're installing batteries. So certainly with batteries, there is a consideration, especially if you're removing lead acid batteries, you want to be considerate of the fact that there can be acid around, right? And I had a lead acid battery leak in my garage very recently. There's still a stain on the floor from that. And I'm well aware that you should keep children away from the acid, etc. And so that's a consideration. And so that's one of the reasons why you would want to wear safety goggles, etc. if you're changing out an old lead acid battery installation. The other thing is certainly if you're dealing with acid, you're going to want to have protective equipment. The nice thing about rubber gloves is not only do they protect your hands from acids and chemicals, but they also prevent you from getting shocked, right? Another one that is mentioned here, so certainly you want testers. This is what's shown in the bottom. There is a Fluke amp clamp. It's one of the ones I have that'll do DC versus AC, and it's about, I think it was $100. You can get them probably cheaper than that, but you want to be able to test your batteries, and DC amp clamps are very helpful for that. In the top right-hand corner, this is one that hits close to home for me. I had students doing research in my lab. One student was hooking up a battery-powered refrigerator that we were doing research on, prepping to take to West Africa. This is a project at a university where I was teaching. And the student had a regular crescent wrench, was torquing down the terminal on the negative side, turned the wrench, and it hit the positive side of the positive terminal. Right, and saw a spark, and he got nervous, right? He got scared, and instead of immediately removing that wrench, he didn't know what to do. Turns out one of my other students who has worked in SimpliPhi in the past was in the lab with him, and they watched this wrench get red hot. So this is the battery was short-circuited across the wrench. So simply having now, luckily that didn't catch on fire. That battery didn't get hot enough to the point where the electrolyte inside would boil, which was what can happen with this was a deep cycle lead acid battery. But look, all they would have needed to use, instead of tightening the terminals with a metal wrench, is a wrench that has a rubber handle, right? And so this torque wrench is there. I specify, getting a torque wrench, because we specify the torque settings on the bolts as you tighten down the terminals. So we do have batteries that come back because people use an impact driver to tighten down terminals, and that can break the brass bolts on the terminal. So I recommend getting a torque wrench like this. And I have a personal story with an experience where this battery got so hot, the lead melted and was dripping down inside the battery. So the battery, the plastic cover of the battery melted through, as well as the lead. So be careful with that. And having an insulated torque wrench, the right kind of wrench, can save you from ever having that problem. Okay, so when you're installing our batteries, remember, have the breakers off. When you're installing the batteries, all of our batteries have breakers. Those are for your safety as well as the safety of the systems. Turn all the batteries off, make your connections. If you don't know the proper way to make those connections, We have resources for you. We have trainings about how to do these installations. Always be careful not to short the terminals, as I just told you a story about that happening. Also, it's very important to never connect two batteries which have different voltages. So when you look at the voltage on one battery and it's different by 1.5 volts compared to another battery, we don't want to hook those two batteries up in parallel. The reason is that a higher voltage battery could rapidly discharge into the lower voltage battery, right? And essentially we have a short circuit condition there. And so you could be, if you have batteries which have more than 0.5 volt difference, we recommend never hooking them directly up in parallel, because that more than 0.5 volt, a volt or so of difference in potential can cause one battery to rapidly start charging the other battery, can damage the batteries, and certainly would void your warranty. So when you're connecting your system, connect that charge controller first or the inverter first, then turn your batteries on. Before connecting a power source, you want to get the correct settings in your inverter or in your inverter charger or in your charge controller, and then connect the charging source, right? You want to make sure to fully charge all batteries before powering loads from them. That's for the commissioning. And if you have questions when you're doing commissioning, feel free to ask us. Give us a call. We never put you on hold with our tech support line. We always have, you come through, we get a ring, we answer it. So you won't be waiting. It's a real quick, easy call. Call us, we'll help you. So I want to point out a couple of things. SimpliPhi Power website is an excellent resource for you. We have manuals on here that tell you how to do things, installation manuals. We have integration guides, and what an integration guide is telling you how to use our batteries with somebody else's equipment. We have integration guides for Solarc. We have integration guides for Snyder, for SMA, et cetera, et cetera. And then there are how-to videos on this website as well. One more thing to point out about our website, and I'm going to mention it to you, is if you are an installer, we have an installer qualification program called the IQ installer. And so if these trainings are helpful to you, we can get you qualified as an installer, which will put you, let me skip this slide for a second, it'll put you on our map. We have several hundred installers around the world installing simplified batteries, and these qualified installers get some extra benefits. One of those is that we will give you, we currently have a promotion, we're giving you $25 back per battery that you install. So if you follow that process, do 10 batteries, we'll send you a check for $100 or $250, right? And so if you install 100 batteries throughout the year, that's a check for $2,500. It adds up. So I want to point that out to you. But one last thing is, if these trainings are helpful to you, we're going to be putting more and more trainings online with Briggs & Stratton Power Academy. There's a training on Briggs & Stratton Power Academy about our batteries and about our ESS, our energy storage solutions. And you're welcome to walk through that training there. We can use that process to help certify you as an IQ installer. The easiest way to go to that, to go to this site, is to just text the word learn to 33988. We won't spam you. It'll just send you a link on your phone, so you can sign up for this Power Academy. Just like all of our trainings, it's free. Okay, last thing to point out again, when you're an IQ installer, we get you on our map. Our customers go here trying to figure out who they should hire to install their batteries. If you're an IQ certified installer, your name pops up on our list, and so we can direct some business to you. Last thing to point out about this installation program is we also have an IQ installer photo contest every month, and just send us a picture. These are pictures that have been winners of our photo contest in the past, and we give you a $250 credit towards your next purchase of SimpliPhi if you win that. And we roll those over too. So if we get 2 really good pictures in a month, we might roll those over. And so take the time to take some pictures of your installations, both for your own business purposes to advertise your business, right? But also to send to us so that we can get you some money back. If you have a nice picture, we're going to ask you to use it and reward you for that. Okay, so last thing, we're almost wrapped up. If you're here for NABCEP credits, email me afterwards. I will check your participation and I can send you the certificate. The email address is here on the screen, training@simpliphipower.com. If you need help, give us a call. We also have a technical support team. Sorry, that line there wrapped at the bottom. The technical support team is 805-640-6700, option number 1. And then if you want to talk to an engineer about designing or buying SimpliPhi systems, or about the capability, or maybe a high voltage, press option number 2 when you dial that same number. So I want to thank you for time, and I'm going to go into the questions and answers section now. Okay, so it looks like I only have one open question here. Daniel answered some of the other ones, so let's take the time to talk about it. I have a customer who wants batteries to store power, but they want to use utility to charge it. Is this possible, or do we need any special equipment? Yes, you can definitely use AC to charge batteries, right? You need a charger that's capable of AC. And so we have AC coupled solar as well, but you certainly can use the grid to charge these batteries. Although Daniel, if you'll unmute yourself, you might be able to talk about whether or not you get the federal credits in terms of charging it. Does the UL 9540A only apply to the inverters mentioned? We have 9540 certification with a number of inverters. I think we have 8 or so different inverters on our website, Jean, and you can check those if you have a question about it. Again, the phone number is on the screen, so give us a call and we can double check to make sure we have 9540 with the particular inverter. You can't mix and match, though. You have to be careful about that. You have to make sure that the batteries are qualified for the inverters that you are installing. Okay, Andonis lives in Hawaii, and he says, we live in Maui, Hawaii. What is the recycling plan for our island? Andonis, I don't know the answer to that right now, but send me an email at training@SimpliPhi and I'll get back to you. We can talk with Inter-Island and R&R in Hawaii and figure out what the recycling procedure is there, but there definitely will be one. An installer in Africa, hello, welcome, John. As an installer in Africa, who can I contact? Who can supply products in Zambia? I met with a number of people last week at RE Plus that were from Ghana, and we've talked about importing those batteries there. We do have installations happening in Zambia. And so Daniel, if you know who to contact, go ahead and answer now. And if not, we can, again, reach out to us at training@simplifypower.com, and we can supply answers to that. We definitely have connections and installations that have happened in Zambia.
Yeah, thank you, Nathan. We absolutely do. And on our where to buy map on our website, I do see we have African Energy Depot, and I did put in their email address.
Great. Yes, and I'm aware of other installations that have happened in Zambia. So thanks for answering that, Daniel. And again, we're always happy to field these questions. One question here from Andy is asking about heaters for upstate New York. So if you're doing external or installations where you're installing in cold temperatures, yes, we do have some solutions for that in terms of heating systems, heating pads, I guess, that go into our cabinets. As well, you can also insulate these cabinets. And so if you have questions about that, please give us a call and we'll talk through that privately.
And we do have an upcoming webinar on installing in harsh environments later in October.
Good. And so just to point that out to everybody one more time, if you go back to our website and you look at our training calendar, there's a installing in harsh environments training. Like Daniel said, we do at least one training a week, sometimes more. And that training calendar is available. So if you click on our website and then click on the support link, you'll see this screen pop up. Click on the training calendar. It has both how-to videos from past webinars there, but also upcoming trainings as well, as if you want to learn about installing in low temperature environments. And I'm happy to talk more with you about that, Andy. There are other things that you can do to ensure that the battery temperature doesn't get too cold or too hot. So all lithium iron phosphate batteries, all lithium ion chemistries are subject to low temperature limitations, right? And you can discharge these down to, I think it's -4 degrees Celsius, so well below 0 Fahrenheit, you can discharge. But in terms of charging, you shouldn't charge a lithium iron phosphate battery at temperatures below freezing, below 32. So that means that's the battery temperature, not ambient temperature, right? So if you keep your batteries warm, or if you have a way to keep the batteries warm, and some people will simply put the batteries in the same case with an inverter or with other pieces of electronics to help elevate the temperature of those battery cells and keep them from getting too low. So hopefully that was enough elaboration, Andy, and if you want more, we can talk about it afterwards, so feel free to contact us. So one more time, I'll scroll down to that number at the end of the presentation, our phone number there for technical support, as well as engineers to help with designing systems is there on the screen. It looks like there's one more question, so let me go to an open question. Do your batteries comply with EU standards and requirements? We have installations in Europe. I actually don't know the answer to that, Gert. I would imagine that they do, since we have installations in Europe. Daniel, can you speak to that?
No, we'll have to check on that. I believe we do. You can email us training@SimpliPhi.
Yeah, thank you, Gert, for that question. I'm sorry I don't have a rapid answer, but I don't want to give you the wrong answer. So contact us and we'll see. And it might be different for different batteries that we have. Some of our batteries have more certifications than others. And so if you call us, we'll check into that specifically for you. Okay, I want to thank everybody one more time for your attention and time today. Greatly appreciate you taking part in this webinar. If you're here for NABCEP credits, please again email me at training@SimpliPhi and I'll get back to you with your certificate. Thank you again. Feel free to direct any questions our way, and if we don't know the answers, we'll get them for you. Thanks so much.